Hello, dear friends! Welcome to the second part of our series on exploring headphone components. First of all, thank you for your comments. I read your comments, review them, and try to act on them as much as I can. So please keep sharing your thoughts. They mean a lot to me. In this video, we are going to take a close look at a headphones printed circuit board. I mean PCB, and explain each component on this board in detail. At the end, we'll have an overview of how the circuit works like a harmonious orchestra to deliver high-quality sound to your ears. Are you ready? Let's get started. Okay, we came to the components on the headphones. At the first, we have a board microcontroller or Bluetooth chip here. The model of this Bluetooth chip is EHE14GBBUAL 8151948. This chip is like the brain of the headphone. It manages everything from Bluetooth connection and processing button commands to playing music, reading files from the SD card, and even sending iode signals to the speakers. The internal structure of these Bluetooth chip are processor core, usually a lower power processor like ARM Cortex underline M that executes commands. The next part is Bluetooth module for wireless communication with phones or laptops. The next part of Bluetooth chip is digital to analog converts to convert digital signals like MP3 to analog sound and vice versa. GPIO ports for communication with buttons, LEDs, and other components. And the next part is timers for precise timing of operation. Interesting note about Bluetooth chip is this chip works with pair programmed firmware, which is like the headphones operating system. Some models even allow firmware updates via the USB port. Okay, the next part of this board is 26 MHz quartz crystal. The role of this quartz crystal is these teeny pieces is like the headphones clock. It produces a precise and stable frequency, so the chip can perform its operation with accurate timing. Why we use quartz? Because quartz crystal oscillates at a constant frequency when voltage is applied. This stability is crucial for coordinating Bluetooth, which operates in the 2.4 GHz band. The frequency of quartz crystal is 26 MHz. Is commonly used for Bluetooth chips because it's precise and energy efficient. A technical note about this object. Without the crystal, the chip can't properly tune Bluetooth radio frequencies, leading to connection issues. And the next part is printed Bluetooth antenna, PCB antenna. This spiral or covered lines on the board send and receive Bluetooth radio waves. The structure of these printed Bluetooth antenna, a metal pattern on the board that acts as an antenna. Its design is optimized for the 2.4 GHz frequency, shared by Bluetooth and Wi-Fi. Why on the board? Because it's cheaper and takes up less space than external antennas. Note about this object here. If the board is inside a metal case, the signal might weaken. That's why antenna design is very sensitive. Now we have 3.5mm jack, IUX here. This port is for wired connection to devices like phones or laptops. It's very useful in hybrid headphones, wired or wireless. The structure of the jack includes left, right channels and the ground. Some models also support microphones, TRRS. When the IX cable is plugged in, the headphone usually automatically turns off Bluetooth to save battery. Now I will plug in this cable, these wires here, as you can see. Okay, the next part is micro USB port. Battery charging. To charge the headphones internal battery, it is one of the usage of micro USB port. Okay, the next usage of micro USB port is data transfer. Some models use this port for firmware updates or file transfers. And now I will show to you like that. Okay, now we came to the connection of micro USB port. It has pins for VBUS 5 volt, D positive and D negative for data, and ground. Okay, in newer models, USB underline C has replaced micro USB because it's faster and more durable, as you know. And the next part is Schottky diode SS14. This diode acts like a guard, protecting the circuit from reverse connection. Example, plugging in the charging cable backward or reverse current. Why we use Schottky? Because it has a very low voltage drop, 0.2 to 0.4 volt, and high switching speed. Usually placed in the battery charging, as you can see here, or cheap power supply. Without this diode, a small connection mistake could destroy the entire circuit. The next part is transistor, 2TY, and the symbol of transistor is Q1. Q is symbol of transistor and 1 means it is the first transistor of this board, okay? So, this component acts like a switch or amplifier. The application of transistor is switching to turn on off sections like the amplifier or charging circuit, and another application is signal amplification to strain weak signals before sending to the speaker. The type of this transistor must be usually an NPN transistor or N-channel MOSFET, okay? And transistors are crucial for energy efficiency, helping the headphone consume less battery. The next part is battery connections. I will be covered in a separate video. It's just mentioned that these connections are used to power the entire circuit from the lithium-ion battery, and the battery is usually 3.7 volt and has a protection circuit BMS to prevent overcharging or over discharging. The next part is electrolytic capacitors, 10 volt and 100 microfarad. These capacitors act like small energy reservoirs, and also they eliminate noise and voltage fluctuations to keep the sound clear, and also they are energy storage for when the circuit needs instantaneous current. They storage energy, and the usage of the electrolytic capacitors is in RAD circuits. Capacitor prevent hum or noise sound. The next part is electret microphone right here. Mic first. Mic means microphone and first means the first microphone of this board. The role of the microphone. What is the role of the microphone? This microphone converts ambient sound, for example, for calls or voice commands, into an electrical signal. It has a sensitive diaphragm that moves with sound waves and generates a signal. We use it for calls, voice assistance, and even recording. Microphone quality in cheap headphones is usually average, but in more expensive models it's much better. And the next part is micro SD card slot for storing and playing audio files like MP3 directly connected to the chip. How it works? The chip reads files from the card, then decodes them, and after that converts them to sound. This feature is very useful for offline headphones, no need for phone. And we have some push buttons here, and also we have it here, the small push button, as you can see. Yes, I do it. Okay, these buttons send user comments to the chip, such as play, pause, changing tracks, or adjusting volume. And the type of push buttons are SPST, signal, pole, signal throw, switch that connect when pressed. Some headphones use buttons to activate special modes like Bluetooth pairing. For example, they said you should push this button for 2 seconds and then Bluetooth pairing starts. Okay. Now we came to resistors. We have some resistor in this board. Okay, here we have it. Here we have it. And the role of resistors is these small components limit current, divide voltage, or protect sensitive parts like LEDs or chips. Seen in button pads, LEDs, or even antennaing here. Okay. And the resistance value is indicated by color bands on the resistor, but not here. Here, these resistors, okay, the resistor value indicated by color bands, and we have another way for count the resistor, power resistor of here. And we have here a wires soldered to speakers. These wires carry the audio signal from the chip to the left and right speakers. Includes 4 lines for left and right channels, positive and negative. We have right positive, right negative, and left negative, left positive here. Okay, and soldering quality here is crucial because a weak connection can degrade the sound. Let's see how these parts work together, because now that we've examined the components, and now it's time for how these parts work together. Okay. The first, we have 5 steps, okay, and this steps has own steps in themselves. The first step is power supply, okay. We have 3 parts here. Input. The circuit is powered either from the micro USB here, micro USB port, or USB-C in newer models, or from the lithium-ion battery. After we have input, we should have protection. This Schottky diode prevents reverse connection and avoids damage. After we have protection, we should have filtering. And for filtering, electrolytic capacitors smooth the voltage to prevent noise from reaching the I/O circuit. Now we finished the first step and it's time for the second step. What is the second step? It's activation and processing. I hope you can see. Yes. Start with the quartz crystal provides here. The quartz crystal provides the base frequency to the chip to start its operation accurately. After we started, we should have some processing. Okay, for processing, the central chip here reads and processes data from inputs like Bluetooth, SD card, or AUX. After we have processing, we should have management here. For management, buttons and microphone send user comments like play or call to the chip. Now we finish the second step and it's now time for the third step. We have here the third step, sound conversion and playback, digital to analog, as you can see here. Okay, the chip uses its internal DAC to convert digital signals like MP3 to analog sound. And after that, we should send it to speakers. The amplified audio signal reaches the left and right speakers via their R positive right positive and left positive wires, okay? The quality of the DAC directly affects sound clarity. Now we finished the third step and now we came to the fourth step. Yes, sound reception from microphone. The microphone converts user's voice here. The microphone converts the user's voice into an electrical signal, which is sent to the chip for phone calls or voice comments. Okay, we finished convert. Now it's time for transmit. The chip transmits the signals via Bluetooth to the target device. For example, phone. Now it's time for the next step and last step. The fifth step is inductors and extra ports. We have some pins here. I will show you VDD, G and D, IO. Okay, VDD means VDD is for power, IO means input output, and G and D means ground. And these pins are used for communication with other components or for debugging and programming. Now it's time for indicators. We have LEDs here. Some headphones use LEDs for indicators like charging or Bluetooth connection. We have LEDs for Bluetooth connection and also for charging here. Now we finish the work of this chip, this board also. Okay, let's do a quick recap. This headphone board works like a professional team. The Bluetooth chip is the brain of the circuit, controlling everything from playing music to connecting to the phone. The quartz crystal, we have it here, acts like a clock providing precise timing. The Bluetooth antenna transmits waves to connect wireless to the phone. The IOX jack here and the USB port provide wire connection and charging options. Diodes and capacitors here protect the circuit and keep the sound clear. We have microphone and buttons allow us to talk or give comments to the headphone. And finally, speaker wires deliver the sound to our ears. All this together make an efficient headphone. Alright friends, we've reached the end of this part. I hope you enjoyed this journey into the world of headphone boards. Did you see how the small components work together like a harmonious orchestra to bring your favorite sound to your ears? From the Bluetooth chip acting as the brain to the capacitors filtering noise, each has a key role. Now, are you ready for a new adventure? In the next part, we are going to explore the beating heart of the headphones. I mean the battery. We'll see how these little batteries provide the energy for hours to music listening, how the charging management system protects them, and why some headphone batteries drain quickly while others last like marathon runners. A question for you. What secrets do you think lithium-ion batteries in headphones hold? Write your thoughts in the comments and tell us what you'd like us to explore more in next videos. If you like this video, give it a thumbs up, subscribe and hit the bell icon so you don't miss the next episode. Until then, turn up your music and enjoy it!